Okay, so let's solve the D block chemistry questions. Okay, so the first question, and that is the question number third, is you can see copper is very slowly oxidized on the surface in moist air, giving a green coating of the verdigris. Okay, so what is the verdigris? You see that whenever we take the copper substances, okay, so initially they are new, but after some time, when this react with the moist air, there is a green coating that is formed on that surface. Okay, so what kind of that chemical reaction is? So you can expect that the copper is react with the water, which is moist air. Okay, so although the CO2 and O2 will be present in the moist air, so the formation will be like this. This Cu, CO3, okay, this CO2 plus O2, they will form the Cu, CO3, okay. And then another copper will be in the OH foldwise, okay, in this form. So this is known as the verdigris in Hindi. This is known as the Tamra kit, okay, Tamra kit like that. So verdigris. So this is the green colored coating. Okay, green coating on the copper material. Okay, so this is, so what is the correct option for this? You can see CuCO3. So this option B is the correct option. Okay, let's move to the next question number. Okay, this question. We have done this question in the earlier video. Okay, so we will not do this, and need to understand which is the correct option for this question number 4. Okay, so let's move to the next question number 5. Which of the following statement regarding the transition element is incorrect? The first is their atoms are contained partially filled d orbitals, so it is correct option. Okay, they are capable of showing the variable valencies, this is also the correct option. And D option, they form the complex readily, this is also the correct. But the C option, you can see that they are colorless. Okay, this is incorrect, and the question is incorrect option. Okay, you need to find the incorrect option. So you should understand that when we talk about these D block transition elements, so they have the tendency to form the colored complexes. Okay, whenever we, we have these transition elements. Okay, so the titanium complex and all these ions. Okay, so they will form the colored ions. Okay, so and here they are saying that they are colorless, so this is the incorrect statement. Okay, you know that transition elements form so many colored ions, colored complexes. Okay, colored. So let's see next question. Color in the transition metal compound is attributed to. So the question is okay, how the color is basically the why the transition metal compound show the color. Okay, so the first is the small size of metal ions. No. Absorption of light in the UV region. This is also not the correct option. Complete NS subshell is not the case, but this B is the correct option, that it is having the penultimate shell is incomplete. Okay, the electrons that are present, okay, that is the N minus 1 p subshell. Okay, so this is incomplete. Okay, so due to this, these transition metal compounds show the color. Okay, now let's move to the next question. This is also very interesting and important one. We have a question on the physical properties of the D block elements. So this is the density of which of the following element is highest. Okay, so whenever we talk about the density, you can expect this formula, density equals to mass upon volume. Okay, and you can say that okay, whichever element is having the higher molecular mass, it should have the high density. Okay, you can think about this, but here in this case, you let me write some data. And for example, if you say the platinum, okay, so this platinum atomic number is 78 and its mass is 195. All right, mercury, its atomic number is 80 and mass is 200, right? Then manganese, atomic number 25 and mass is 55. Okay, and copper, atomic number is 29 and it is 63.5, that is, you can say almost 64. Okay, so you see that these having the very low mass. Okay, so low mass, you can say that their density will be low. Okay, so you can eliminate these two options from these four options. Okay, so they cannot be the choices for your possible answers. Okay, but if you see the platinum and mercury, so this is very interesting. You know that the mercury is present in the liquid state and platinum is present in the solid state. Okay, if you take the concept of the mass, then you see that mass of the mercury is higher than the platinum. Okay, so you can say that the mercury is having the higher mass, so it should be the highly dense. Okay, density of the mercury should be higher than the platinum, but this is not the case. Because there are some other things that you can consider while doing this. Okay, you can consider their mass. Okay, what are the things that you can consider in this question? You can talk about the atomic masses of these elements. Then you can think about the atomic packing. Okay, atomic packing of the atoms in these elements. And then you can talk about the interatomic forces. Okay, interatomic forces. So these are some things that you keep in mind in during this question. So if you talk about the atomic mass, so you neglect these two options, manganese and copper. Now atomic packing, when you talk about the atomic packing, it means that how the atoms in the elements, they are atoms of elements, they are packed. Okay, so in case of the platinum, you see that this is the, in solid state chemistry, this is the FCC kind of the packing. Okay, phase cubic center type ka, that kind of the packing will be present. Okay, and if you talk about the, but because the mercury is in liquid state, so that kind of the solid packing is not present. Okay, the packing is not present, good packing is not present. Interatomic forces, you can also say that in the platinum, due to the solid state structure, FCC structure, interatomic forces are higher, but in mercury the interatomic forces are lower. Okay, so that's how we do the first option. Okay, that is the platinum is the highly dense element in all these choices, right? So let's move to the next question. uh, these questions we will talk later. Okay, now let's move to the next questions. Question number 10. The 3D metal ion form the colored compounds because the energy corresponding to the following lies in the visible range of the electromagnetic spectrum. And we have these options. Okay, so basically the question is, you know that the 3D metal ions show the colored compounds. Okay, so why this colored compound is basically formed? Okay, when they will absorb the electromagnetic radiation of the visible range, they show the color. Okay, so but what is the reason? So the correct reason is their DT transitions. Okay, so you will learn about DT transitions, that how the DT transitions take place, and these elements will show the color due to the DT transitions. Okay, now let's move to the true and false. Okay, next section. Okay, next section. Okay, so let's move to the section 2, true and false kind of the statements. So here you can see that you know, the acidic potassium permanganate is used in the organic chemistry under the name of the Bayer's reagent. Okay, Bayer's reagent is very important reagent. Okay, this is very important reagent in the organic chemistry. But remember that potassium permanganate. What is the Beer's reagent? Beer's reagent is the K2Cr2O7 plus alkaline medium. Alkaline medium, you can say the NaOH. Okay, so alkaline is required over here. So that kind of the solution is known as the Beer's reagent. Okay, and this is very important reagent for the organic chemistry and organic synthesis. Okay, but here the option is the acidic potassium permanganate. Okay, so this statement is false because the Beer's reagent is not the acidic potassium permanganate, it is the alkaline potassium permanganate. Okay, so remember this point. Now let's see the next question, number 2. We have the Fe2SO4 whole thrice and this iron 3 sulfate, and this formula is this one. So you can see that in this Fe2SO4 whole thrice, if you do the ionization, okay, so you will see Fe2 Fe plus and SO4, 2 minus, like that kind of the thing. So if you take the oxidation state of the iron, so 2 times X plus SO4 whole thrice, okay, SO4 whole thrice, so that is the 3 times minus 2, okay, so this will be your 0, 2x will be minus 6, then x will be plus 3, okay, x will be your just a minute, yes, this will be your plus 6 and this will be your plus 3. So this is the complete iron plus 3. Okay, so iron is present in plus 3 oxidation state, so this is the true statement. Okay, let's move to the next question. Copper dissolves in hydrochloric acid, so this is the false statement. Okay, copper can't be dissolved in the hydrochloric acid. Now let's see this next question. We have the dye-positive zinc exhibits the paramagnetism due to the loss of 2 electrons in the 3d orbital of neutral atom. So if you say that zinc, so the zinc, its electronic configuration is 3d10 4s0 4s2. Okay, so now we are talking about the zinc plus 2, so zinc plus 2 will be 3d10, and 3d10 means there is no unpaired electron, and if there is no unpaired electron, so you can say they are diamagnetic. Okay, they are diamagnetic, that is the diamagnetic, so this can't be the paramagnet. Okay, so this is the false statement. Okay, diamagnetic means it is not susceptible to the magnetic field. Okay, now next question is the silver is found in the nature both in native and combined state. So silver, yes, you can say that silver is least reactive like the gold. Okay, reactivity series, if you see, then silver is very less reactive, but in some cases you can say that this will form some compounds, okay, like silver Ag2O type compound, silver chloride type things. Okay, so this is the true statement. Next question is the electronic configuration of the element copper plus 2 is this one. So if you say the argon 3d9, argon, you know that argon is 18, and if you add the 9 electrons, it will become the 27, right? And the copper plus 2, you know that copper is 29, so its electronic configuration is 3d10 4s2 4s1. Okay, but copper plus 2 will be 3d9. Okay, 3d9, and 3d9 means the total number of electrons will be 27. Okay, 27 electrons are here, 27 electrons are here, so it is the true statement. That's why it is true. Okay, next question. Fe3O4 is mixed oxide of FeO and Fe2O3. So if you talk about the ferric oxide and this Fe2O3, okay, so you can expect that once they will react with each other, they will form the Fe3O4 kind of the adduct. Okay, so that kind of the adduct you can say. Okay, adduct formation kind of the reaction, you can say it is a true statement. Okay, now here question number 8. this question number 8, you can see the metal are present in the divalent cation form. All the elements are the 3D series elements. Okay, so if you see the zinc plus 2 and scandium plus 2, then in case of the zinc plus 2, you know that zinc plus 2 contain the 3d10. Okay, 3d10 means no unpaired electron, and no unpaired electrons means, okay, no unpaired electrons means there is no unpaired electrons means there is no free electrons. Okay, and this is the mu is the, what is the dipole moment? Mu is n plus 2 in Bohr magneton. Okay, so because it is not having any unpaired electrons, so you can say that mu will be 0. Okay, but in case of the scandium plus 2, there is a 1 electron. Okay, 1 unpaired electron, and that will be, you can say that this is not equals to 0. Okay, it means that magnetic moment of the scandium plus 2 is higher than magnetic moment of zinc plus 2. Okay, so this state, this is option is, though this is state, so the given set of these options is false. Okay. Let's move to the next question, and this next question is, according to the definition, mercury belonging to the 6th period of d block element, and it does not come under the transition element. So let's see, you have the idea that this zinc, cadmium and mercury. Okay, this is the element 3d10, cadmium is 4d10, and mercury is 5d10. If you talk about the periods, okay, so this will be your 4th period, this will be your 5th period, and this is your 6th period. Okay, so it is also true that it lie in the 6th period. Okay, but the thing is that they are not the, they does not come under the transition elements. Okay, why they are not the transition elements? Because in all these cases the d orbital is fully filled. Okay, so that is why you will say that these zinc, cadmium, mercury, okay, the mercury is not the transition element, so this statement is true. Okay, now let's move to the assertion and reason kind of the questions. The first question is, highest oxidation state of osmium is +8, and osmium is a 5d block element. Okay, so this is true, and the assertion is true. Remember here, assertion is true. Okay, assertion is true, but the reason is false. Okay, assertion is true and reason is false, so you can make some different options here. Assertion is true and reason is false. Okay, osmium is +8, it can show, but the reason is not the correct. But assertion and reason both are true statement. Okay, assertion and reason both are correct, and reason is not the correct. Yes, both assertion and reason are correct, but the reason, option number C you can write. Okay, assertion and reason both are correct, but reason is not the correct explanation of assertion. Okay, so this question number 2 we will do it later, and let's move to the question number 3. Assertion is potassium permanganate has the different equivalent weight in acidic, neutral and alkaline medium, and reason is in different medium change in oxidation number shown by manganese is altogether different. So if you talk about the potassium permanganate, which is a good oxidizing reagent, you know, and you can take this potassium permanganate in all these 3 cases. Okay, you can frame their neutral solution, you can frame their acidic solution, and you can prepare their alkaline solution. Okay, so definitely one thing is very clear, that if you are changing the solvent, okay, and that is acidic to alkaline to neutral, so definitely there will be the change in the equivalent weights. Okay, so this is the, both assertion and reason are correct, and reason is the correct explanation of the assertion. Okay, so this is your option number A. Next question is, the magnetic moment of manganese +2 is less than the chromium +2. Okay, magnetic moment of manganese +2 is less than that of the chromium +2. So once you will say what kind of the explanation on this. Okay, here we have some options different. Remember that here we assertion is true. Okay, assertion is true, but the reason is false. Okay, reason is false. All right, so manganese plus 2 has the less magnetic moment than the chromium. Okay, and why I am saying this kind of the thing is when you talk about the manganese plus 2 and chromium plus 2, so chromium plus 2 you will say that 3d4 and 4s2 kind of the thing. Manganese plus 2 you say that 3d5 and 4s2 kind of the thing. But when you lose the number electrons, okay, so what kind of the situation will be there? This will lose and it will become the 3d5. This will become the manganese plus 2. This will become the 3d5, right? And this will chromium plus 2. This will become the 3d4, right? So here you can say the 5 unpaired electrons, right? And here we have the 4 unpaired electrons. So as in the first case we have the more number of unpaired electrons, so their magnetic moment should be high because magnetic moment is mu, and mu is under root n plus 2. Okay, more the unpaired electron and more will be the magnetic moment, right? So, and the reason is higher the atomic number, smaller is the magnetic moment. So the reason is very correct. Okay, reason is correct. Higher the atomic number. Let me have some. Yes, reason is very correct. Okay, so reason is correct, but the assertion is false. Okay, reason is correct. Reason is correct. Okay, true, but assertion is false. Okay, why? Why I am doing like that kind of the thing? Assertion is false. Manganese plus 2. Okay, assertion is false. Magnetic moment of manganese plus 2 is less than that of the chromium plus 2. Okay, magnetic moment. So assertion is false and the reason is true. Higher the atomic number, smaller is the magnetic moment. Okay. Suppose you are, for example, chromium and manganese. Okay. Chromium is 24 and manganese is 25. Okay. Manganese is 25. So you can understand one thing that as the as the atomic number is increasing, okay, as the Z increases, that is the atomic number increases, then there will be increase in the, there will be, what will be the number of unpaired electron will decreases. Okay, number of unpaired electrons will decreases, and as the number of unpaired electron decreases, then magnetic moment mu also decreases. Okay, so this kind of the thing you can understand here. Okay, and this will help you to sort out the things. Okay, this will help you to sort out the things. So you can say that in this case the assertion is false and reason is true. Okay, all right, assertion is false and reason is true. All right, so let's move to the final question. White precipitate of silver chloride is soluble in ammonium hydroxide. Okay, and reason is it is due to the formation of the soluble complex. So this is also very true, because whenever you take the silver chloride with ammonium hydroxide, okay, the reaction is like that. This ammonium chloride will form and this silver hydroxide kind of the thing you can expect. Okay, so it is both assertion and reason are true, and reason is the correct explanation of assertion. Okay, so that's how we have solved this paper. Thank you.